Hi, I'm Benny D, and in this video we're going to be looking at power functions. Okay, so if f of x equals x to the power r, and r is rational, then f of x is called a power function. And in reality, power functions are very similar to polynomials. Okay, it's just, remember with polynomials, poly means many, so a polynomial just has many parts that have rational powers. Okay, we're just worried about where we've got a single term in our function and r is rational. So that could be that it's a whole number, it could be a fraction though as well. Okay, and what we want to talk about first is looking at strictly increasing and strictly decreasing functions. So a function is strictly increasing on an interval if x2 is greater than x1 implies that f of x2 is greater than f of x1. What's that actually mean? It means it looks something like this. Okay, it's always got a positive gradient, okay, between x1 and x2. So if you're walking across the page this way, okay, left to right, as our numbers get bigger, you walk across this way. If you're always walking uphill, then we say it's strictly increasing. Okay, our definition of strictly decreasing is a function is strictly decreasing on an interval if x2 is greater than x1 implies f of x2 is less than f of x1. Okay, what's that mean? Well, it's the same idea here. As we walk across our page from smaller to larger numbers, if we're always walking downhill, if you like, they're strictly decreasing. Or if our gradient is always negative, it's strictly decreasing. Okay, so we want to have a little bit of a look at some specific examples of power functions. Okay, so power functions with positive integer index. Okay, so if we've got an even function, an even function, so powers are even here. Okay, this is what it's going to look like. Okay, this is a classic example of looking at something that's somewhat parabolic in shape. Okay, as we increase that power, this value of r up the top, what happens is we basically get a bit flatter. We come up steeper, we're going to be on the inside here, and then we get a bit flatter at the bottom, and then come back up. Okay, is essentially what happens. So I've exaggerated it there a little bit, that this point here is always going to be the 0.11. Okay, because 1 to the power of anything is still 1. So when we, and same over here with our negative 1, so we're always going to go through that point, but as our power gets bigger, beyond that we're going to increase quicker. So we, on the inside, when we're lower than 1, we actually drop down quicker, and that gives us our flatter bottom. Okay, when we've got an odd function, so that means that our power is now an odd number. Okay, it's going to look something like this. Okay, and this is our typical cubic sort of looking function. You don't tend to think of x being a power function because it's just a straight line, but it actually is. Okay, and again, what happens when we're looking at this, when we go up higher powers, we're going to go to the 0.11 again here. Okay, and we're going to increase quicker. And our flatter part is through the middle here. So we're a bit flatter there. We're going to come through 0, 0, a bit flatter, and then through and down a bit steeper. Okay, so it's going to do that general shape. Okay, and just note this is a strictly increasing function. Okay, so these odd functions are going to be strictly increasing. Okay, what happens if we've got a power function with a negative integer index? Okay, so for our even functions now, so that's now where we've got y equals x to the negative r, and this is an even power. Okay, that looks something like this. This graph is called truncus. Okay, this is a specific case here where we've got 1 on x squared. Okay, it's a truncus because it looks like the base of a tree trunk. Some important points to note on a truncus though, it actually has 2 asymptotes. Okay, so we've got a horizontal one here, okay, at our x-axis, a vertical one here at our y-axis. Remembering that an asymptote is a line which our graph will get infinitely close to but never touch or cross. So that's going to happen this way. So we'll get closer and closer and closer to this line but never touch. It's going to happen this way as well. It's going to happen from this side and from this side. Okay. Again, what happens if we make this an even power but bigger? Okay. Again, we're just going to come in here. So we're going to actually come through and we're going to be a bit closer in here. So it's going to be kind of a skinnier one. Okay. How about odd ones? Okay, for odd ones, this shape of graph is called a hyperbola. Okay, and again, actually it has two asymptotes, which is the x and y axes here. Okay, but you can see this side now sort of flipped down. Okay, so we have those alternating sort of quadrants there. So this way, our function is going to get closer and closer and closer to 0 but never touch it. This one's going to get closer to infinity but never touch it. Same with this way, closer to infinity and closer to infinity this way. 0, sorry, this way. Okay, as we approach infinity. So we've got those asymptotes happening in both of these. We'll see that you've probably seen these functions before in your studies in year 11. Okay, so hopefully this is a little bit of a recap of that stuff. Okay, and we've got one last little bit to look at as well. But what happens now if our index is just a positive integer? So it's a fraction now, though, we can have. Okay, well, when and so for that, sorry, we've got it set up as f of x equals x to the power 1 on n. Well, when n is even, this is the shape that we get. Okay, and that's y equals x to the power half, and you might recognize that being y equals the square root of x. Okay, and it looks like this. Note it's only the positive one. Okay, we're not using plus or minus it, which you might have seen. Okay, we're just using the positive part for this. Okay, it's going to have this general shape. That's going to hold. It's going to look very similar to this again if it was x to the power 1 on 4, 1 on 6. Okay, it's just a bit of a dilation there. Right, when n is odd, okay, there it has this shape. Okay, and so this is our example of x to the power of 1 on 3, but it had this same general shape. It was 1 on 5, 1 on 7, etc. Okay, and note that this is actually also strictly increasing. This one is true, but it's not always true that that's going to happen, because we've got this one last little note here that if f of x is an odd one-to-one function, then f to negative 1, or inverse f of x, will also be an odd function. So if we look back to our odd function here, okay, you can see here that we've got this relationship between this function, okay, and this function in terms of their shape. Okay, and it's because they are actually inverses, and because this is strictly increasing, it's a one-to-one function. Sorry, because this one is strictly increasing as a one-to-one function, this one will be as well. Just because it's an odd function. Okay, it's just a little special property of our odd functions there. So just a little bit more knowledge around our types of functions, what they look like, what their properties are. So hopefully that will help you out and get you through.